afternoon, people. My name is Sakshi, and I am part of the Nullcon team. Thank you for joining us today. For those of you who are new, Nullcon's Security Conference is a unique platform for security enthusiasts and professionals to showcase their research and technology to the community. We have our upcoming event, Nullcon Goa 2022, happening on the 9th and the 10th of September. The focus of the conference is to showcase the next generation of offensive and defensive security technology. So in addition to that, we have also announced 15 hands-on training sessions. So if you want, you can check it out, all the information on our website. And coming to our today's speaker, we have with us Tzah Pahima. Tzah is a cloud security researcher at Orca Security. He specializes in vulnerability research and web security. And an interesting fact, before joining Orca, Tzah served for 5 years in an Israeli military intelligence unit. So on behalf of all of us, I would like to welcome Tzah.
Thank you. So as been said, my name is Tzah, and I'm going to present today my research on AWS. The research was called Breaking Formation from an error message to AWS infrastructure. So without further ado, let's get right to it. So a little bit of introduction. As said, my name is Tzah Pahima. I'm a security researcher at Orca Security, which is a cloud security company. This is my Twitter account. I did serve in the military for 5 years in IDF. That's a little bit about me. And the first question I like to always answer is why, right? Why am I doing what I'm doing? Why am I showing this, or why am I researching AWS at all, or doing cloud research? So our team at Orca, we're a two-man team, and our team is responsible for thought leadership. What this means is we want to generate high-quality research. Then with this high-quality research, we want to sort of be on the forefront of cloud vulnerability research, right? Be in the public conception, be in Twitter, be active, post things about cloud vulnerabilities and security, and engage with the community. And the second reason is like more of a personal reason. I want to gain cloud expertise, right? So researching the cloud will help me get to know the cloud better, be a better expert on the cloud, and so forth. So this is why I'm researching the cloud at all, and why AWS specifically. Then first of all, it's the largest by market share, right? It's the largest cloud provider. And second thing, it's a challenge, right? Because there were not a lot of attacks on AWS infrastructure up to pretty much this vulnerability, right? No real public vulnerabilities about the server side vulnerabilities in AWS. I'd start with like a quick introduction to the cloud. So we always hear like this buzzword cloud. What exactly does it mean? So we have a lot of cloud providers, obviously AWS, Azure, Oracle Cloud, Google Cloud, Alibaba, and so forth. But we want to introduce to the word of the problem so we understand exactly why is cloud so important. So let's say I want to set up a database. Pretty simple. Now, what do I have to do? I have to go to the hardware store. I'll buy a computer. I'll install my operating system. I'll install the software. I'll make sure it's up to date. It's secure. No vulnerabilities. Make sure it's connected to the internet. Then I pay like an internet provider and everything. So this is a lot of overhead just to get started, just to build a database. So what happens if, for example, my house where I have the database burns, right? Goes on fire, right? Database is shredded, it's ruined. I don't have no backups. I need to make sure it's always online. I need to make sure it has backups, it's encrypted, it's secure, whatever. All of this, I need to make sure the cloud does it for me. That's the point of the cloud. If I want to set up a database, 2 clicks, I have a database. It's always online. It's always backed up. It's always up to date and secure. Same for file storage, same for virtual machines, whatever. Every problem that I have, I don't need to do IT system, all of these kind of stuff, like up to a degree. I just pay the cloud provider does it for me. So AWS is no different. AWS is an acronym for Amazon Web Services. It's the largest cloud provider. We've said it, and it has over 200 different services. What are services? Can be multiple different things. For example, EC2, if you look at the corner top left, is the virtual machine service. Lambda, you can deploy your own code. There's S3 where you can store files. MODBs, database solution, RDS as well. You have plenty of different services, different categories for your needs. I pay the cloud provider, I use whatever services I need, and I pay for them. Now, another keyword in AWS is regions. So there are services, there are regions. What are regions? Basically, every service has multiple data centers that it works on. So for example, S3, where I store files, I might want to store my file close to me. If I'm in Israel, I'll find a data center that's close to Israel so I can download my file or upload it pretty quickly. If my customer is in the United States, I'll choose a region that is closer to his state, for example. So these are regions in AWS. There are like over, I think it's over 80 availability zones, which are like sub-regions in AWS around the world. And a little bit of cloud security, because we're going to talk about a cloud vulnerability. So we need to understand what exactly is the way that AWS secures their cloud. So the major principle that cloud providers promise you as a customer is called tenant isolation. What is tenant isolation? Tenant is pretty much every customer in the cloud, every different company. And the isolation means that even though you and me might share the same machine, the physical machine, and have two virtual machines on it, or we might share the same hard drive. I store my files in S3, you store your files in S3 at the same data center. Even though it might be the same server, I can't access your data, you can't access mine. Pretty simple. That's tenant isolation. And AWS specifically has this thing called the shared responsibility model, which goes like this. Everything that I can configure is my responsibility. Everything that I can't control, AWS guarantees it's going to be secure. So if we take the example of EC2, which again is the virtual machine service, then everything above operating system level, including the operating system, is my responsibility. If I choose a weak password, if I choose wrong permissions to save my files, if I install vulnerable software, it's on me. But for example, the drivers, right? The network drivers, or the hard drive itself and its drivers, and all these hardware that I can't control because it's not mine, it's AWS, then they guarantee there will be no response, there will be no vulnerabilities there. Now, most of the vulnerabilities found in AWS have to do with the customer configurations. It's easy to misconfigure something. Okay, might be easy, but it's a vulnerability in how I act. Not a lot of vulnerabilities in what AWS is responsible for up till now. Okay, let's get to know a little bit about CloudFormation, which is the vulnerable service. So we need to get to know the villain, right, of the story. So CloudFormation is actually 11 years old. This is a typo here. It's 11 years old. It was established in 2011. And it's an infrastructure as code service. We'll understand exactly what it means, but we need to understand two keywords when it comes to CloudFormation. One is templates, one is stacks. CloudFormation accepts a template, that's the input, and outputs is a stack. What are templates and stacks? Also, they have a Twitter account, so you might want to go and follow them there. But what exactly are stacks? Okay, stacks are the output, remember. So stacks, collection of resources managed as a single unit. That's all there is to it. What are resources? Everything. A file in S3, resource. A virtual machine is a resource. A firewall rule is a resource. Whatever, all of them are resources. And they're managed as a single unit. And what are templates, which are again the input to CloudFormation? The recipe to a stack, right? So all of the resources, there are types, the data. You can also have like parameters, rules, and conditions, whether or not to set up certain resources. And it's in the format of YAML or JSON. So you can have two formats. This one to the right is in a YAML format, and it has two resources. One is an EC2 instance. EC2, remember, virtual machine. So this is a VM. And you can say you have like the CPU in here, right? The CPU type. You have the name. You have a bash script that will install an HTTP server on it and start it. And the second resource in this template is a security group. Security group is a firewall rule. So we say we accept transportation from port 80, like to port 80. So this means this is an HTTP server. We open port 80 and we allow access. Pretty simple. Okay, so we have templates, we have stacks. Why should anyone research CloudFormation? Why is it an interesting service? So first of all, first thing that I look for as a researcher is features, right? Attack surface. If you have, if a service does only one thing or two things, not very interesting, but it has plenty of features and it has a parser, right? Like a YAML parser, a JSON parser, and it has plenty of different resources that it touches and does things and parameters, conditions, whatever. It's interesting. Second thing is templates can contain sensitive customer data. The template earlier had a bash script. It can also contain passwords, can contain a lot of other things. And the third most important thing is it's a high risk service. What this means is some services don't do a lot of interesting things, only do some sort of configuration, for example. This one can deploy and provision resources in accounts. In my account, for example. But if I take over the service itself, maybe I can provision resources in other accounts that could be very destructive. So that was the idea. But all of what I told you is true, but it's also sort of a lie because it's not the reason I started researching CloudFormation in the first place at all. And the reason, or let's start with what I researched beforehand, was actually I researched two different services called CloudTrail and CloudWatch. I had a purpose. My purpose was bypassing logging mechanisms in AWS. CloudTrail does logging in AWS, and I wanted to evade detection. That was my research idea. Nothing about CloudFormation, didn't know of the service and its existence. How did I get there? Let's see. Pretty simple. CloudTrail, first of all, we need to understand, which is, again, what I tried to research in the first place, tracks user activity and API usage. Everything in AWS, everything is an API call, right? So if you look at, you have, one second. Cool. So in EC2, for example, rebooting your VMs is an API call. Signing credentials, API call. Creating a bucket in S3, bucket is where you store your files in AWS in S3. It's an API call. Changing the permissions, API call, etc. Databases, whatever, everything is an API call. And CloudTrail logs these API calls. And what do you do? How do you create a trail? That's how CloudTrail stores logs. Basically, you set whatever events you want to trace. Management events are things happening in your account. That events are things happening to your resources. Doesn't really matter, but you create this sort of trail, then it starts logging things. Now, how does a log look? It's JSON. It has pretty much three different interesting components. It has a lot more, but three main ones. One is who did a certain action. In this case, the service CloudTrail did performed an action in my account. What did it do? Here, it did a put object API call on S3, which means uploading a file or writing a file. And how did it do it, right? Parameters. So CloudTrail puts an object in S3 in this bucket. It has the file name, it has everything. So these are the logs. It has who, what did it do, and how did it do it? right? The circumstances. Cool. So this about, we talked about CloudTrail a little bit. My purpose was doing things inside of an AWS account without getting logged into CloudTrail. How does CloudTrail get me to CloudFormation? This is how. Yoav Alon, the CDO of Orca, and my team leader said to me, Zach, Tzah, there's this new feature, has to do with CloudWatch, which is sort of a dashboard to display logs. It says there's something about widgets and dashboards. Look there. It's an interesting new feature. Maybe you can find something there. So I said, okay. I entered the link and I entered the samples, and I found like it has different widgets, has sample widgets. I went into the first one and I got into this page. This page says CloudFormation stacks, quick create stack. Now, what was weird to me here, what I noticed is, first of all, you can see CloudFormation at the top. I didn't know what CloudFormation was back then. And you see a template URL, HTTPS, blah, 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 to an S3 bucket. Right? If you look closely, right, then you have this S3 bucket. And it has like a YAML file, which again makes sense because we said it's a template. Templates can be YAML or JSON. This is a YAML template, whatever, makes a whole lot of sense. But what was weird to me is that S3 links are usually not the HTTPS scheme. They're usually S3://. So it's either you have like a bucket name that you just put in the API, or use this format. And I'm saying S3 as a scheme, and it's really everywhere in the API, in the UI user interface. You can always see S3://, and then you put a path to S3. Never this HTTPS thing. It works, right? S3 is accessible by web, but it is still weird. Never seen it in the API before. Now, why is this so interesting? Why does it matter? If it's S3, it's HTTPS, it doesn't really do anything, right? But the idea that I had to do with SSRF. And what are SSRFs? It's an acronym for server-side request forgery. It's sort of attack where an attacker gives a server a URL, and this server accesses that URL. Now, if a server accesses my own URL, then it can be a URL to Google, and it can be a URL to the internal network, and it can be a URL to localhost, and then the server accesses itself from the inside. So SSRFs are generally interesting, and in the cloud, they're even more interesting. Why so? There's a thing called IMDS in the cloud, which is instance metadata service. It's a static IP address, 169.254, and so forth. And you can access it from any virtual machine and any service pretty much in AWS. And it provides sort of configurations and metadata about your instance. And it can even include credentials. Now, this is very interesting because back then, there was this Capital One hack. Some of you all might remember. It was a hacker team that gained like access to 100 million or even more credit card applications and accounts of Capital One, which is a big banking corporate. And how they did it is they managed to have an SSRF. They accessed this IMDS, this 169.254 IP address. They got credentials, and from these credentials, they found data stored in AWS of Capital One. So this is why SSRFs are interesting, specifically also in the cloud, in this AWS thing. So for now, all I have is this template URL, right? Which is HTTPS:// whatever. And I said, okay, this is where it comes from. Let's try to change it. I want to make it access 169.254. If I get it to access the IMDS, again, IMDS, the place where you can get maybe credentials and configurations, then maybe I can get something interesting to happen. So I went to the URL, I changed it. Just tried an invalid URL, literally, and I got this error. Template URL must be a supported URL. Okay, so now I get there's some sort of filtering. And I looked, I opened the burp suite, which is a proxy, HTTP proxy, and then I can see the requests going from my browser to AWS, and I saw this path, right? It goes to the console and .aws amazon.com, and it goes to this path, CloudFormation service template summary, and a passes template URL, and I get a JSON with the error back. Now, when you put a valid URL, right, to that HTTPS URL to the YAML, right, we already know this here. Then you just get a JSON back without an error, like JSON of the summary. Okay, so I know what the behavior should be, and I know what the error is, right? When I put like an invalid URL, I get an invalid URL. When I put a regular URL, I get a JSON. Now I wanted to try to understand what this is. What is this request? So I went to Google and I Googled CloudFormation service template summary. Literally, whatever it says here, this is exactly what I Googled, right? And what I found is this page. Get template summary is a CloudFormation API call, returns information about new or existing template. How do I know it is mine? It's irrelevant. Is because it has a parameter called template URL, which is location of file containing template body. Remember, template is either JSON or YAML, and it's located in Amazon S3 bucket. Okay, so what do I have left to do? I want to try and get it to go to INDS, right? That is the purpose. I want to access internal things. I don't want to access normal S3. So what I did is I tried to bypass that sort of filter because it says template URL must be a supported URL. I want to make sure if I can somehow bypass it, make it access whatever I want. So there's this new regular URL, which is the HTTPS, ends with the YAML, right? This is a normal template. And we know it bypasses the filter, or it passes. It's not a bypass. It really just is how it's supposed to work. So I said, okay, let's change it a little bit. Instead of HTTPS, let's try HTTP. The same URL, just HTTP. Worked. Okay. I said, let's make sure it really works. Let's try to change the scheme to something totally nonsense, blah, blah. Shouldn't work, right? It did work. By when I say it works, I mean it returns the normal JSON with a summary. It really can access that YAML file. It accesses it and parses it. Okay, so it ignores the scheme. That's what I understood. Then I said, you know what? Let's try to cut straight to the chase and get to the INDS. Put the URL. It says template URL must be a supported URL, right? It's supposed to be located in Amazon S3 bucket. This is not how an Amazon S3 bucket URL looks. Makes sense. I said, okay, let's try the same URL exactly, the CloudWatch thing, S3, different port, 1337. It worked. Return normal JSON. So it ignores the scheme. It ignores the port. It probably only uses the path and the host name. I said, okay, let's try and fool it, do like an @ symbol, at like S3, CloudWatch, whatever, at evildomain.com. See what happens. It should get to my domain. It was sort of a trick, but it says it must be a supported URL. What I understand from here, there is real legitimate URL parsing. It is going to be a bit hard to bypass. So I said, you know what? Let's not bypass the filter. Let's just put a URL to my own test bucket, right? So what I did is I created this back in Blue Hat. So I literally created a S3 bucket called the Blue Hat test bucket, right? Which is also a conference. So in Blue Hat test bucket, I created and I put empty file called existent. That was the name. And I wanted to see what will happen. So I got a different error. It was template format error, unsupported structure. It means it worked, right? It accessed it, but it says, okay, this is an empty file, nothing to do here. Then I tried non-existent file, which does not exist, and it says S3 error access denied. This was weird to me. S3 error access denied was kind of weird. Why? Because when you access this URL yourself, you get this sort of error access denied, and it shows the same error. I was like, okay, there's something weird here. But I didn't find no vulnerability up to here, so I kind of lost my nerves. And I said, you know what? Let's get back to the logging. Remember, I'm researching CloudTrail at this time. Let's get back to the logging. I said, okay, black box is hard. Nothing makes sense. Let's get back to CloudTrail. And I looked at CloudTrail and I found logs. Why? Because CloudTrail is responsible for logging. What are the logs that I found? I found this log saying, okay, there was a get object, like someone tried to access my S3 to Blue Hat test bucket and a file called existent. And who did it? CloudFormation did it. Makes sense. I told CloudFormation to access there. It did it. But there was one thing that was weird. Remember, it accessed existent and it accessed non-existent. Regarding non-existent, there were two logs and not one. One makes sense. One says CloudFormation did a get object, to Blue Hat test bucket non-existent. But the other log didn't make a lot of sense. It gave like an IP address, someone called like with the user agent Apache HttpClient, unavailable Java with a version, tried to access my Blue Hat test bucket non-existent. I'm like, who's this? I know the CloudFormation accessed. I don't know who this is. So I started a little bit tinkering with the behavior, like tinkering with the API, and I got to a conclusion. There's this thing happening behind the scenes. I access CloudFormation, I give it a URL, right? And I say, give me the template summary, get template summary. CloudFormation accesses my S3 bucket. If it somehow fails, for example, the file was non-existent, then it approaches the HttpClient by Apache, and it says, you know what, you access it. You will try and access the bucket. Why? Sort of a fallback, maybe to get the error, maybe to see if it's somehow accessible publicly, whatever. But Apache HttpClient also accesses it. So I said, okay, HttpClient, let's Google a little bit. And I found a CVE, like a vulnerability, but I wasn't sure if it's going to work. I tried it. You just put two @ then it sort of fools HttpClient. It thinks that it's going to access S3, but it's actually going to access my evil domain. Tried it, didn't work. At this point, I was kind of desperate and I said, okay, I know about this weird behavior. Nothing really works about bypassing the URL filter, but I know that HTTP clients can do one more thing. You have URL parameters. Remember, the scheme doesn't work, the port doesn't work, this @ trick doesn't work. Maybe URL parameters are going to do something. I searched for parameters in AWS. There's a parameter called XAMZ security token, basically used for authentication. You need to combine a few parameters to use it. And I said, okay, let's try it in the API. I just did the same Blue Hat test bucket / non-existent. Non-existent because only then Blue Hat test bucket approaches, right? If it's existent, then Apache HttpClient does not go into action. And I put this URL parameter. And I said, okay, let's see what's going to happen. When I approach this with my browser and I open this Blue Hat test bucket link, I get this: access denied, no AWS access key was presented. Now, when I access it with the API, it says S3 error, no AWS access key was presented. So there is error parsing here, literal error parsing. I was excited, but this was like a Thursday, so I was going into the weekend. Now I'm a Jew, I'm an Orthodox Jew. So what this means is that from Friday evening, like to Saturday evening, I don't use electricity. I can't write, can do all these kind of things. But I was only thinking about this. I was only thinking in my head about what I knew. And what I thought about was the error extraction. How come AWS, this CloudFormation thing, how come it knows what the error from S3 is? It literally accesses it. So I knew a few things. I would say to myself, okay, HttpClient can parse the error from S3, right? Because one time it says access denied, one time it says no AWS access key was presented. It can parse the error. And I know the URL parameters work. And I know this is only a fallback. This only happens when the resource is inaccessible, only when it's non-existent, for example. So I knew it parses, I knew it parameters work, and I knew it's a fallback. I said, okay, combining these three things, what can I do? And it dawned on me. I was just about to take like a nap, and I came up with an idea. What was the idea? A race condition. And what sort of race condition? Let's see exactly what a race am I talking about. I'm going to CloudFormation, giving a URL. It accesses S3 bucket. Fails because it's a non-existent file. Now, before it approaches HttpClient and before Apache HttpClient accesses the bucket, I said, okay, right now, right here and there, I want to upload that non-existent file, make it existent. Then CloudFormation accesses Apache HttpClient, and then it accesses the bucket and it retrieves the file. Now, why is this so interesting? Because it parses the error. And I thought, okay, let's put my own error there, see what happens. Let's try and put an XML code. This is literally my error. This is what it says inside of my file. And I'll try and see what happens. Worst case, won't work. But if it will work, might be interesting because it says it can parse my own errors. So I did it. How did I do it? I operated burp intruder, which basically just sends requests back and forth. And I did a shell script that instead of creating a file, it makes the file non-existent, public and private. So it's either access denied or you get the file. But if it's exactly in the correct time, then CloudFormation will fail and Apache HttpClient will succeed, and we might get inside. Okay, so this is how it works. The shell script is on the left, the burp intruder is on the right, and it starts sending requests and it iterates private, public. Now, there are two types of errors. One is template format error unsupported structure, which means CloudFormation found the file, tried to access, it was public, and it says this is an empty file, it's not a YAML, it's not a template, unsupported structure. The second error is when it's private. The error looks like S3 error access denied because CloudFormation and the HttpClient both couldn't access it. But I found a third error, which was S3 error. This is literally my error. Again, CloudFormation fails. The file turns public. Apache HttpClient succeeds and parses it. Now, why is this so interesting? Because it parses the S3 error by me. And this error is an XML format. Why are XMLs interesting? For this very reason. XML documents, and I'll go over this pretty quickly. There's an attack called XXC over XML documents. A normal document will look like the one on top, which has like a root element and different elements. And rendered, the text would be like 4 A's. Then you can have things called XML entities, which are, if you want to use a character that means something, for example, lower than or greater than, then you have a way to encode it in XML. In this case, %LT is a way to encode the lower than symbol, right? So rendered, it will look like this, A lower than B. Now you can also define your own XML entities. So in this case, if I want to be a wrapper, for example, right? So I can define an entity called MC, which says chika chika, entity called me, which says Tzah Pahima, and rendered, this would look like, hi, my name is chika chika, Tzah Pahima. Very nice. Now, how is this a vulnerability? Not yet. You can define external entities. What are external entities? You can define an XML entity, in this case, one called not malicious. And if you add the keyword system, then you can put a URL to whatever you want, and it accesses it when it renders. So file etc passwd, then nothing to see here, and rendered, you can guess how it should look. I said, okay. HttpClient parses XML. Only some XML parsers are vulnerable to XXC. I said, let's give it a shot. And I gave it a shot. And I did the race thing again. And I put my error message with an entity, like a malicious entity. And I got this thing in response. S3 error, not access denied, not this is literally my error, S3 error, and the etc passwd file of that AWS server. And the reason it is censored is because plenty of AWS employees and their names are found here, so we had to censor it. But it was amazing, like 28 requests in, there it was. It just worked. The race worked, and it had an external entity attack. Now, I love race conditions. They're not too practical. Why? Because it takes like 30 requests for one result. So I tried to exploit it in one request, and I did it. I'll cut it to chase. There's a thing called bucket policies in AWS. Basically, you can put a policy saying, okay, deny everyone from doing things in my S3 blue hat test bucket unless they're called HttpClient. And how this works now is I go to S3, I upload this file called non-existent and the policy, and it certainly locks the bucket. Now, only one with a key can access it. Now, when I go to CloudFormation, it accesses the bucket. It fails because it is locked. And Apache HttpClient can open it. Why? Because its user agent contains the word Apache HttpClient, so it unknowingly has the key, opens the bucket, gets the error. Easy. How it looks, pretty simple. Oh, pretty simple. 1 second. Like this. I have a script, creates a bucket, creates the policies, whatever, and it's censored, obviously, but you can get in one request, you can get to exploit and read files. What can you do with this? You can read files, which is what we did up to now. When you try to read a directory, you can get their listing, which is very, very interesting. And you can have SSRFs. Why? Because you can access a URL. In this case, it's a file URL, but you can access whatever URL you want, HTTP. And this is interesting because the cloud has IMDS. IMDS, remember, configurations, credentials. We can make it even more interesting, but I sort of lied to you. Why? Because there is a protection against IMDS. The protection is IMDS v2. What it does, it means, okay, it doesn't make sense that one request can give me whatever credentials I want. You need to make 2 requests. One is a put request with a certain header. Then you get a token. Then you use that token. Basically, you need to have a session. So this exploitation shouldn't work. And AWS also says you need to disable IMDS v1. Just click on here, and they have an article called Use IMDS v2, and they say they recommend adopting v2 and restricting access to v2 only for added security. But factually, when I tried it and I ran my script and I tried to access 169.254, this should fail. It didn't fail. I got metadata. I got credentials. Happy Hanukkah. And I can't show the credentials, but I can show the success. I tried to use the credentials to understand who this is, and I got AWS service, AWS internal. These were the credentials that I had. We had in the palm of our hands, and we stopped here. We disclosed it to AWS. It was deployed within like 25 hours. They had a patch. It was very quick. It was fully patched within 6 days. And I should only probably state these kind of things. First of all, these were not CloudFormation's credentials. It was not a service credentials, right? So we were not like the highest permissions. We were like an AWS service. We were from AWS internal, but not more than this yet. We didn't explore too much further, but we did find like internal configuration files inside of the machine and like internal services that we can access and internal credentials and whatever. But we do believe from other research we performed in AWS that if we would have escalated this more to an RCE, right, from an XSE, which means reading files, SSRFs and whatever, to an RCE, we do believe that this would have led to severe cross-tenant violation in the CloudFormation service. And I'll just shortly say the takeaways, which are, first of all, black box is hard. This is like sort of like a strike through. This is just like a reminder, right? It's very hard to try to research something when you don't have the source code. AWS in particular is just a giant cloud provider. Second thing is logical vulnerabilities are really a thing. This one is like a race condition leading to an XML external entity. And you say like, how can someone think of these? And it's really hard. You need to be creative. You need to, I don't know, think about this a lot of time, but it still works. There are still logical vulnerabilities, even when you don't know the source code. You can just think and read about the API and sort of succeed eventually. No platform is infallible in the sense that everyone will have vulnerabilities, even AWS. But cloud is more secure. Why? You've heard about log4j, I assume, for example. It takes months, days, weeks, even sometimes years to patch this in all servers because it needs to be maintained. In this case, we reported the vulnerability 25 hours, like less than a week, and no one else is vulnerable to this thing ever. So this was pretty cool. And you might want to watch us on Forward CloudSec. We have different vulnerabilities we're presenting in Azure and AWS. It's going to be super, super cool. Thank you, guys. My name is Tzah Pahima. This is my Twitter account if you want to follow. It was an honor presenting to you.
Thank you so much. What a great presentation. I am so sure our participants must have found some knowledgeable inputs via that. Guys, thank you for joining the session. And in case you still have any questions, Tzah has just dropped his social media Twitter account. So in case you have any further questions, you can ask him or reach out to him through his Twitter. Thank you. Bye.
Thank you. Bye.